So this is AP Calc Bc 2013 FRQ, question number 2. The question asks, the graphs of the polar curves r equals 3 and r equals 4 minus 2 sine theta are shown in the figure above. The curves intersect when theta equals pi over 6 and pi equals 5 pi over 6. Question A. Let S be the shaded region that is inside the graph of r equals 3 and also inside the graph of r equals 4 minus 2 sine theta. So that's the shaded area right here. So to do that, we have to set up our integrals. So we know when it intersects, pi over 6, and over here is 5 pi over 6. So we can go from pi over 6 to 5 pi over 6 of which graph? So you see this one here. So it's going to be the 4 minus 2 sine theta. Now, for the area of a polar graph, you gotta do 1/2 and square this. Don't forget d theta. Now that's just this area here. We also gotta figure out the rest of this. So here, let me clear this up a little bit. So we found the area from here to here, but like there's everything here left, and that's from the circle. So in this, so if you can tell from this, it's a 6 pi, but at first I couldn't tell, so I had to do it another way. I did this. I did the integral from 5 pi over 6 to 13 pi over 6, which is also this point, but like just rotate like around one time. And for r equals 3, squared 1/2, don't forget that, d theta. Now for this, you're allowed to use a calculator, so use our calculator. We'll do, I have a TI Inspire, so everyone else's calculator might be different, but I'm going to teach you how to do with an Inspire. So go to menu, calculus, numerical integral. We'll type in pi over 6, 5 pi over 6. Now we're going to do our 4 minus 2 sine theta, whole thing squared, d theta. Okay. Alright, and don't forget the 1/2, so divide by 2. That's this one, 5.85. So this is 5.85917. To do this part, 1/2. We'll start with the 1/2 first. Calc, go to calc, numerical integral. Oh. Okay. 1, 2, calc, numerical integral from 5 pi over 6 to 13 pi over 6, 3 squared, d theta. Okay, and we get 18.8496. Add that up, we use our calculator, and our answer comes out to be 24.7087. That's the area of S. Now, to check our scoring guideline, we'll come down here. As you can see here, they did area equals 6 pi plus 1/2 of our integral that we already used. We used this here. Because from the graph, they saw that the area of the circle from 5 pi over 6 to 13 pi over 6 was 6 pi. I didn't see that at first, so I showed you how to use the integral. And you get 24.709, or 24.708. And we got 24.708. Alright? And they gave you 1 point for the integral, which we did, 1 point for limits and constant, and then 1 point for the answer. Now let's move on to part B. A particle moves along the polar curve r equals 4 minus 2 sine theta, so that at time t, theta equals t squared. Find the time t in the interval for which the x-coordinate of the particle's position is -1. Now, if we remembered correctly, you get to memorize this. X equals r cosine theta for polar graph. For the polar chapter, I mean. Now, using this, we can figure out what x is, because they've given us r. Okay. Now, they also tell us that theta equals t squared, so let's just plug that in. X equals. Now they want us to find the x-coordinate of the particle's position at -1. So we have x here. So we want whatever t is. We want to find t. We want to find the t that's going to give us -1. So -1 equals 4 minus 2. So parentheses here. Now this looks like a really hard problem to solve, right? But we can use our calculators. So I'll show you how to use it with our Inspire. Go to menu, algebra, numerical solve. Now we just plug this in. 4 minus 2 sine t squared times cosine t squared equals -1 Now, don't forget the comma t to indicate the variable. For Inspire, you have to do that. I'm not sure about other calculators, but hit enter, and we get t equals 1.42798. So this answer tells us that at this time, the x-coordinate of the particle's position will be -1. Now let's go check the scoring guideline. Yeah. So they use this, x equals r cosine theta. They set it so that 4 minus 2 sine theta cosine theta equals 4 minus, they plugged it in, the t squared. They also set it equals to -1. So they used that, used their calculator, and they got the same answer as we got, 1.428. Well, they rounded it, we truncated it. Anyways, so they gave us 1 point for x theta or x of t. They also gave us another point for setting it equal to -1, and then another point for the answer. Okay, now part C. For the particle described in part B, find the position vector in terms of t. Find the velocity vector at time t equals 1.5. Part C. Now remember these equations? You're going to need these for this one. Position vector, r. Now, instead of theta, we'll use it in terms of t. And in part B, they told us theta equals t squared, so we'll do t squared. This is the position vector of x. Now y. I don't need that. Yep, position vector. We found that. Now we need to find the velocity vector at time t equal 1.5. Now, you might look at this and be like, okay, I gotta take the derivative of this. But since we can use our calculator, it's a way easier thing to do. Don't forget that, or done at t equals 1.5. So using our calculator, menu, we'll go to, for the Inspire, I couldn't find a shortcut to find the derivative function. So I just used the library and then found derivative here. Now in terms of t, remember? Now we'll plug it in. We'll do it for the x first. 4 minus 2 sine of t squared times cosine of t squared. Now for this part, you have to set it so t equals 1.5. We use control, hit this button. Down here, we'll use that. And we'll type t equals 1.5. And we'll get -8.0721. That's x of 1.5. Now we need to find this part. Same thing. Use the library, derivative, t. Plug in our equation. 4 minus 2 sine t squared times sine of t squared. We use the same thing, control equals, go down to this bar thingy, type t equals 1.5. And we get -1.6729. That's our vector velocity at t equals 1.5. Now let's look at our scoring guide. So they did the same thing. They said y equals r sine theta, and they did it in terms of t squared, which we did. Found the position vector, which we also did. And then they plugged into the calculator and got the answer. Now let's look at the points. They gave us 2 points for our position vector and 1 point for our velocity vector. So after this video, you should definitely get a 9 out of 9. Thanks for watching.